We got to change the game.
Earlier this week, we probably had 3 customer meetings that were all really, really good. Some key customers, I have to say. And this weekend, I went on something called an SF Hills ride, which I've not done in ages. It's a 5-hour ride through all the hills of San Francisco.
Wow.
It's a bike ride through all the hills of San Francisco. And that was enormously fun. I was not sure if I was fit enough to do that, but ended up being a lot of fun.
Oh,
so
nice.
That's my last few days.
Oh, that's amazing. I also saw your the webinar you did on Tuesday.
That's right. The panel discussion, or the webinar, sorry, was that yesterday, I think? Yes? Or I'm confused. No, day before yesterday. You're right. That was really good fun. Enjoyed it thoroughly.
Yeah, that was a great conversation. So I talked to Joe, obviously, so I've already gotten the Clockwork pitch. And then I was able to listen to it, and it really, a lot of things started clicking for me.
Nice.
And for me, like, I've been selling infrastructure my entire career.
Right.
So this is cool.
No, like, exactly.
There hasn't been anything really cool in a while.
I completely agree, Sandesh. I think, it's the last 15 years, we've become so used to the cloud abstracting away all infrastructure and almost basically not having to think about networking, not having to think about storage, not having to think about compute. It all comes from, so you're really operating above that layer for the most part. And then the world of AI and AI infrastructure, data centers are back with a bang. Hard.
Yeah, for sure.
It's actually one thing I will tell you when we talk to so many of these neo clouds or even people trying to put up on-prem infrastructure, the skill sets have disappeared. People that really understand these domains don't exist anymore. Of course they do, but not in anywhere near the numbers needed to fund the kind of infrastructure build out we're seeing.
That was one of my big takeaways.
I should go back to building data centers.
I know, Chris.
Yeah, Chris used to be a CTO building data centers. He's built 300 feet. To tell them about the one that you built.
I built an EMP shielded data center 250 feet beneath a mountain.
Oh my gosh, I'm curious what was in there and why it needed to be EMP shielded, but that sounds cool.
So it was some government work. And
yes, I imagine.
It was an insurance company, actually, that wanted the EMP because they wanted to, we're like, well, there's not going to be much for you after the EMP to do anything. Yeah. They're like, yeah, at least we'll have the arrays with all the claims data. I'm
nice.
Like, okay, you do you. But it was wild, man, because this facility was absolutely massive, and it was the facility itself was a full acre underground. It had its own zip code. It had its own fire department. It had a lake in it that was the chill water plant for the whole thing. And the lake kind of ran off the backside of the mountain, so there's never any risk of flooding with it either.
Right.
And the mining engineer who managed the whole thing, he would get into this boat with big hip waders and stuff like that, and get in this boat with a flashlight and a can of spray paint, and he'd be like, "If I'm not back tomorrow, come look for me."
My gosh,
they didn't even know where the lake was.
And fun.
Everywhere the lake went.
You should. Your skills will be in high demand, Chris, at the moment.
Well, and it's funny because a lot of the guys who built the black site in Utah for the NSA, same crew who was doing the EMP shielding, and they made me think twice about a career in security. Like I don't want to live with that kind of paranoia.
Yeah, I know exactly.
Yeah, it's funny like how it all kind of comes back around, right? Like you said, from the infrastructure folks now going to the cloud. So now those skill sets are not there, but there's also this uniqueness. We won't get into it. The uniqueness of high performance computing, these GPU powered environments, in my mind, and I think probably most people, they just think it's hardware, it's servers and it's CPU, chips, and it just works. And there's storage and there's been networking around for years. What's the problem, right? So like what's cool for me is like there's new problems to solve.
For sure. Oh my gosh. First, how much the energy density of the data centers that you're putting these into is totally different. So where do you get the power from? Then the racks are basically dissipating a lot more heat, and they have a lot more power draw. So you have to change the racks all over. The cooling has to be completely redone. The cabling per server is roughly 8 to 10x the connection density of just because, where a traditional server might have a couple of NICs, these modern servers have 10 NICs in an 8 GPU server and far more in a 72 GPU server. And these are roughly operating at somewhere between 4 to 8x the bandwidth of a per NIC on a traditional server, right? And so you start doing the math on every front. That's part of the reason why failures are so rampant in this environment, because almost everything is an order of magnitude faster, hotter, denser. And so that means things are just operating at the edges all the time.
Yeah. Yeah. Well, I remember building, we would home run fiber and all these big single mode bundles would be like this big around. And they'd make the racks come down from the ceiling because they were so heavy.
Right. No, exactly.
And the problem is you can never, ever remove a cable because where's that cable go? I don't know.
That's right. No, that's exactly right. That's exactly right.
No matter how well you label them, you still just can't trust it.
Yeah, exactly.
Pulling them through is going to, can disconnect things and break things too. So it's too risky.
Exactly. We have one large customer where our contract, we typically price on a per GPU basis and per agent or per node basis. And they basically priced it on the base of where we are deployed, what's the kilowatt of the racks in which we are basically deployed, if you will. And so it's almost like the unit of scale has become how many kilowatts or megawatts are basically able to be deployed in a data center context. And so it's completely, the constraints are quite significant on a lot of fronts.
Yeah, sure. The cooling's the hardest part.
Yeah,
for sure.
Indeed.
You can get the power there. It's scary. Some of the power they're putting into these small racks.
Water cooled systems and crazy cooling structures. Exactly. Yeah. Exactly. And then you start peeling the onion on, I still remember the days when petabytes were massive. And now you're just starting to see more and more of these large scale data centers talk in exabytes as if it's just it's sort of in a heartbeat. We've gone from terabytes to petabytes to exabytes. And so the amount of data, the network bandwidth and the speed latency that you need, just every angle of the infrastructure design, you're pushing the boundaries. That's what's making it fun. Because in some sense, I don't know if you recall, right? Before virtualization, the idea that servers were operating at 30, 40% utilization because you could really virtualize the application. It was a single application per server. It was the mindset. And then virtualization came around and you could cram 6 or 7 VMs onto a single physical machine. You started increasing the utilization. We're back into utilization for other reasons, not for very different reasons, but we're talking about utilization in the 30, 40% zone. We're talking about availability that in the cloud is measured for compute, 4 nines or 5 nines. We're not talking about 92, 93% availability for the compute instance, because the rest of the time it's just there are failures that have taken the system down. So on some dimensions, we are pushing the boundaries so hard. On other dimensions, we feel like we have to solve problems that have been solved all over on things like resilience, fault tolerance, and so it's funny.
At some point we used to talk about like tier 3 and tier 4 data centers, right?
Right.
And like to have a tier 4 data center, you have to have staff on hand all the time that are HVC, AC engineers. You have to have electrical engineers. You have to have like those skills present and available all the time,
right.
in addition to all the, 2N pathing and stuff like that. And like we were seeing the change, and it was like, it doesn't make any sense to do that. It makes more sense to just make your infrastructure more fault tolerant. And that was sort of that rise of the SRE world where like,
that's right.
And then it's like, let's just design to what the capabilities of this platform are and build, to accept that. And that's where I think we've kind of landed. And so like those failures are sort of built into the system.
Exactly. And that will happen here too. We're just in such an early innings on rethinking infrastructure for AI that the first focus has been speed, speed, speed. Right now, we're starting to say, well, security matters, resilience matters, observability matters, automation matters. And so, because in the end, those things actually don't take away from speed. They just make it possible for you to operate in a much more predictable manner. And so I think you're starting to, and unfortunately, part of it is also the technologies are needed to achieve those very same things, whether it's fault tolerance or deep observability. While the discipline is the same, the technologies are very different. The distributed communication protocols in training are not built naturally with the ability to do sort of a retry after a timeout automatically. Don't let a failure in the network propagate up to the application layer. Those are well understood principles of protocol design, but that's not necessarily how distributed training works today, right? And so there's many things that I think will evolve for sure, Chris.
Well, you should talk to. I talked to Vijay Pandey at. He runs. He's like the VP and general manager of Cisco Outshift.
Right.
And I don't know if you're familiar with Cisco Outshift, but it's sort of their like internal incubator. And so, like,
I'm not actually. Yeah.
The two projects that he's working on, like, sort of longer term horizon projects. One is sort of quantum networking, which is really an interesting thing. They've got a chip now at room temperature that'll entangle 200 million photon pairs per second.
Wow. Okay.
And they can send it over like normal fiber optic, and then do like quantum teleportation and things like that. Because the problem is, like, with quantum computers, is like you can get to 1,000 qubits, but you need like 100,000 or a million. And it's hard to do that. So, like, they're like gambling on, like, well, let's put 100,000 qubit computers together with quantum networking, and then just make it easier.
Interesting.
But the other problem they're focused on in the shorter horizon now is network of agents. That's what they call it.
I see.
They're building all the new protocols for inter-agent communication in an AI world. So they're doing all that work to tie it all together, like kind of some of the protocol level stuff. They're like kind of rewriting the whole stack to like integrate AI and inter-agent communication. So you should reach out to them. I can give you.
I'd love to. It seems like both. I mean, gosh, they are sort of bleeding edge problems to attack.
And they're putting together a working group around this right now.
Okay, so they're very helpful, especially given the focus on communication.
Yeah. I mean, I'd love to put you in touch with that. With them.
I think we're going to change the name of this podcast to Nerd Talk.
Nerd Talk.
I think
I love it. I love it.
I knew you two would.
Well, you got to love a nerdy CEO.
Yeah,
you don't encounter them too often.
And that's the fun of being in a startup. Otherwise, if otherwise you might as well join a large company. At least that's what I thrive on.
Yeah.
Great stuff. I'm just going to get started here. We're already recording, and the reason why is because of what just happened. I know that we're going to get some great clips, and our team will edit it, and we'll give you everything. People will be looking up Cubics and whatever else you guys are. Yeah, I see.
Although now you just you created a new company.
Exactly right. There you go. Exactly.
I'm the sales and marketing guy.
You squint and there'll be a new technology based on Cubics. It's love Qubits, I'm sure.
Cubics, the quantum AI company.
Yeah, exactly.
Smart people will be like, I wonder what that is.
Yeah, indeed.
So I want to ease into this, Suresh. It's going to be very, very casual.
Perfect.
But I like in the beginning to give you some softballs. What we're learning is people want to know what you think. And, this podcast, we're calling it What the Future, because that's what we're trying to do is figure out what is the future, right?
Right.
So just a couple of questions around the AI bubble. I want to ask you about that. And then just a little bit about what Chris was just talking about too, is like you're a technical CEO, but, I will kiss your ass here in a second and brag about how awesome you are. But like I really respect you as a leader, mostly because of what people say about you. To me, it's off the charts. So there's a lot of speculation these days on if we're in an AI bubble. What's your thoughts?
I think I'll say two or three things. One, I think we have to separate out what's happening in the stock market from the technology side of it. That's the first thing I'll say. Because I think on the technology side of it, I think it is one of the most incredible developments in the last 1,000 years in terms of transformative power. I do think people that say the AI revolution is like the industrial revolution are not at all overstating the case. I think what we are on to is the beginning of something that will change everything about sort of how we live, work, and do day-to-day stuff. Some good, some bad, but it will be transformative for sure. That's the first thing. On the stock side, almost all great big changes have been accompanied by some excess, followed by sort of a reversion to the mean, and then some sort of a couple of hype cycles, if not more. And so it's possible that we're going to have a stock market sort of crash for AI valuations in particular. That said, here's one thing that struck me. If you look at the amount of spending, let's take NVIDIA for a moment and say, if you look at NVIDIA's revenue and say, how much of that revenue is coming from companies that are using other people's investors' dollars to buy NVIDIA product, which would be the classic sign of a dangerous bubble. I would say a vast majority, probably 75, 80% of their revenues are coming from really large cloud companies that are able to fund their annual capex out of their annual cash generation. That is so that almost puts a floor on how much frothy revenue exists here that's not coming from people with real operating cash flow. So it's possible that the stock market valuations will come down. In fact, they look super crazy high. That said, I also think there's a floor here because I think there are real business models underpinning the purchases of AI infrastructure.
Yeah, I was going to say, I think it's really interesting to see like what happened with Amazon recently, where, they had this massive layoff, but they sort of pinned it on AI, but when you dig into it more, it looks like they actually laid off all those people so they had the money to buy more GPUs.
Exactly. I mean, yes. Yeah. So when I said not all good, I do think we'll go through a sort of a period of turmoil when it comes to employment and sort of reskilling, and there'll be so jobs displacement is one of the penalties of what will happen over the next few years. And so on the one hand, you're seeing companies make completely unprecedented profits compared to any prior year. And those very same companies are also saying we have too many people in our payroll and we need to shrink the payroll. And so that is unfortunately both happening at the same time.
I think it's very funny. Like we talk about people being replaced by AI, but I mean, these people are literally replaced by a GPU, which almost seems
exactly right. It's actually
it seems a little bit more insulting.
That's right. That's right. That's right.
Oh, that's classic.
That's right.
Well, on the subject of people, so you are seen as a great people leader. And I remember those days at NetApp when I first met you there, and you were just promoted. You became CEO of Nimble, CEO of Sysdig. You've had an amazing career. But what I really appreciate is, as every time I've met you and been with you, it's always been such a pleasure, easy conversation. And like, it feels like you care, And I think that was a lot of the NetApp kind of culture, right?
For sure.
No one cares what you know until they know that you care. So I'm curious, how would you describe your leadership style, balancing people, but also the rigor and to be tenacious in this market?
Well, and I think you got the passion too, which is a really big part of it as well.
No, I appreciate that, Chris. I think I'll start by saying something, Sandesh. I feel like NetApp was basically a 10-year school I went to. I learned so much at NetApp that even sort of dimensions on how to lead companies or organizations or teams, I feel like I learned a lot from mentors like Dan and Tom at NetApp. And so NetApp, I credit a lot for sort of over the years how I've at least been leading organizations and teams. And I think there are a few simple principles. I do think the starting point for me is almost a belief that the team actually can accomplish a lot more than any talented individual. And so to harness the power of the entire team, you have to essentially set great context. So real transparency in communication, make sure that so I typically do 50 to 60 one-on-ones in my last company, Sysdig, where we had an employee base of 600 every month, sort of 50 to 60 one-on-ones. And so try and talk to as many people, establish context, and have a very free sharing of information so that there's great transparency in the entire culture. That's the first thing that I would say is extremely important. And ultimately, the goal is a deep belief that a group of individuals that may be individually not as smart as one particular talented individual will always do more if they can work sort of with really good shared context. That's the first thing I would say. The second thing I think is a clear sense of purpose. I feel like organizations need to know they're working towards something. And frankly, in tech companies, that sense of where you're heading has to come from a technically grounded perspective of what is the vision that we're working towards? When we succeed, what will the future look like? So let's paint a picture of the future. And in a tech company, that picture of the future has to stem from almost an understanding of where the technology will go, how we can intercept it, and then getting people excited around it. And so that's the second thing I would say is just imbuing the entire organization with here's what our destination looks like and why that's a good place to go is probably the second thing that I would say is key. And then I would say one other thing is, culture really matters, right? And so what I mean by that is these are about where you go, sharing of information is how you operate. But also what is valued in the company. At Sysdig, we had a principle. At Nimble, we had a principle which was basically no jerks, right? And so it doesn't matter how smart you are. If you're not fun to work with, then you're probably not going to make for a great team member. And so the culture matters, and it's things around how people are rewarded, what is sort of lauded in the company versus what's frowned upon in the company. And so essentially what you encourage as behaviors within your team, within the larger organization, and is that creating a collaborative environment? So that's probably the third thing I would say. And that, Sandesh, you know this, I absolutely saw that very much at NetApp, and that's something that stuck with me.
When you mentioned sort of the vision part, because I totally agree with you on all these things. And I think what I see leaders struggle the most with, I think, is communicating an effective vision
right.
and sticking to it, because right. In a lot of organizations, the lack of vision, because if you have the vision, everybody marches towards it. And right. You don't have to tell people to do stuff. They just kind of know where they're going.
That's right.
That's the best way to do it.
That's right.
Like, what are the tricks to like really communicating that vision? I mean, I guess one of them is have a good vision to start with, but yeah.
Yeah, so I think there's a couple of things that I would say, because I think having a vision that is the clearer it is in your head, the more I think you should be able to translate that to multiple layers of the organization. The same vision when you're talking to the finance team and how you're communicating it, or when you're talking to a business decision maker on the customer side and how you're communicating it, is very different from sitting down in a room full of engineers and architects and how you're communicating it. And so I think, and I believe the ability to translate up and down certainly comes from having good communication skills, but it also comes from clarity around the vision itself. So I think that's the first thing I would say is when you have a vision, find ways of communicating it, even if it takes explicit work to do so at various levels. A one-pager all the way down to a deeply technical document that describes the architecture of where you want to go has to be very, very, that has to exist in the organization.
Yeah.
The second thing I would say is...
Oh, sorry, go ahead.
No, please go on.
No. Second thing, please.
Yeah, the second thing I would say is so much of our energy is spent on how do we communicate that externally, whether it's in our first call decks, whether that's in our website messaging, etc. I think more of the battle is really in synthesizing it internally to employees and making sure they are bought. So find forums, right? Whether it's written forums, all hands meetings, team meetings, etc. And actually, this is something I did not do really well, and I continue to sort of struggle at this. Is you feel like sort of if you've communicated it 5 times, you've done enough, or if you've done it 10 times, you've done enough. And I find, gosh, there's no amount of repetition. Find different flavors of saying it. Don't say it the same way each time, but you have to keep coming back at it. Every new product, let's go back to our vision and why this new product fits. Every new customer that we want, let's go back and talk about why did this customer become a customer, because they bought into our vision and here's how it fits in. So I feel like that's something that you have to do also, consistently articulate what your vision is in a way that sort of you don't feel like you've done it if you've done it a few times.
Yeah. You're so spot on. The third point that you made about culture, for Chris and I, that like hits right in our heart,
Indeed.
Because we're
Indeed.
it is we were spoiled at NetApp, right?
I could not agree more. I joined NetApp from another company, McKinsey, the consulting firm, and just the honest truth is, there's been so many scandals around McKinsey lately that sometimes it's hard to remember. But when I joined McKinsey, it was I think there was a book comparing it to the Jesuit priests or something, because they were so sort of evangelical about what their mission was and so on. I was very proud of the organization, and I still am, notwithstanding sort of the noise around McKinsey. But part of what I was going to say is another place where the entire product was people and the expertise of the firm, right? There was no technology they were building. And so they had to, it's a different style of culture. NetApp's culture was beautiful in its participative nature, et cetera. McKinsey's culture was all about sort of fostering talent at the expense of everything else, right? So sort of how do you take the brightest minds and motivate them and sort of keep making sure that the organization maintains a high bar on talent? But what is common to both of these is ultimately, how do you take whatever it is that you believe in and make that percolate through the entire organization? Whatever your culture is, how do you reinforce that and make sure every person's living that? So it's almost that's what NetApp did so well, is sort of it was a strong culture, but how did every employee, whether it was the 100th employee or the 1,000th employee, seem to embody that culture? I think they did that really well.
And the other thing that helps culture is when you have a very successful sales organization, from sales team to architects and anyone supporting the sales team.
Yeah.
If they feel they're winning, if they're coming into work every day, they believe in the vision, they're excited about what they're doing, they feel like people have their back, they have good leadership, guiding them. Those kind of qualities is why people stay at companies. I firmly believe a lot of people don't stay at these companies because of money. They stay there because of other factors.
Indeed.
I know for me, that's definitely the case, is the people.
No, for sure. Practices like Tom calling not just salespeople who close deals, but engineers that help close deals and support people that help support the customers that ultimately did expansions. Those allow everyone to focus on success, rewards everybody, right? And so I agree.
Yeah. I got to tell you this quick story and then we'll get started here on the Tom Mendoza topic. So a really good family friend of ours, my wife's best friend's daughter, they live in our neighborhood here. And she got into Notre Dame, and her.
You know what? Before you go there, you should explain who Tom Mendoza is.
Oh, I think
not everybody who's listening is going to know who Tom Mendoza is.
I think our audience definitely does. But Tom Mendoza was, when I started in '98 at NetApp, he was the director of sales and marketing. He then became president and vice chairman, and now he's on a bunch of boards. And he's also
the Mendoza School of Business.
The Mendoza School of Business, and just that story when he tells you about how that all happened, it's just so awesome.
Indeed. And Tom and Dan were sort of great partners in shaping that entire company's evolution.
Yeah, totally.
For sure.
So our family friend's daughter is going to Notre Dame. It's a freshman year. She's a little, just like anybody would be, a little nervous. And I just reached out to Tom and I just said on LinkedIn, hey, she's going to Notre Dame, as a freshman. She's super excited. She's, wonderful person, wonderful family. Dad went to the Mendoza School of Business too. Would you mind just sending her a note? He's like, send me both of their phone numbers. And he created a video for each of them and sent it to me.
Gosh.
So
he
Tom
is just
Mendoza.
amazing that way. That is, he makes time for these things. That's what is amazing.
So important. Especially these days in the world of work from home and, social distancing and distractions of these phones and devices. I'm very, very, very big on the humanity side. That's why our three pillars are enterprise and AI, tech sales, and humanity. Because we can't forget that's why we're all humans.
Agreed.
First.
Agreed.
Right?
Agreed.
Yeah.
Agreed.
Well, let's dive in a little bit. So, Suresh, for people that might not know you, can you just tell us a little bit of history of your from your young ages to kind of what history. Brought you? Yeah, what brought you here? How'd you get to where you are now?
Yeah, absolutely. So I was born and raised in India, did my engineering undergrad and business school in India. And then I joined McKinsey, the consulting firm, in the early 90s. And towards the late 90s, I transferred to the US, to Chicago in particular, with McKinsey, with the intention of going back after about a year of a short-term stint. But that's when a friend of mine had joined NetApp, and when I visited him, it became clear to me that the excitement of the late 90s, this was 98, the excitement of the Valley was just completely impossible to ignore and get drawn to. And so I left McKinsey to join NetApp, and I almost spent 10 years at NetApp. That was really, in many ways, the beginning of my tech career and tech education. And I joined as an individual contributor, managing one of our alliances with Dell at the time, moved gradually into product management and then onto the exec team to run engineering and product management. And so that was one of my most fun 10 years stints where I learned an enormous amount. The last 2 years were interesting in that while I was running R&D and product management, I had just come off of a year and a half of running a business unit that we had acquired, a company we'd acquired. That was my first virtual CEO experience because there's a security company called Dicru that NetApp we decided to structure it as an independent business because it was partnered with EMC and other storage companies. And to give it a chance to survive, we needed to think of it as an independent sub with its own sales, own marketing. That never panned out when EMC acquired RSA. The idea of an independent security subsidiary that would partner with EMC did not make any more sense. And so we merged it back, but the 1.5 years of running a full business sort of unfortunately spoiled me in the sense that I did not want to go back into a functional role after that. I loved the idea of running an entire organization and the business, not just the product. And so that's when I left. And since then, I've just been doing startups. Chris and Sandesh, I was at, my first startup was a company called Omnion. Also an interesting experience. This was when I joined, they had an S1 on file. Dumbest timing-wise, dumbest time to have left NetApp to join because it was 2008 towards the end. So when I joined, the revenue was something like 37 million. When I signed the offer, 8 weeks later, when I joined, it was about 23 million. And so really the bottom had fallen out of the market. We had to pull the S1. We had to restructure the business. But ultimately, we were acquired and it had a successful exit. And then I think began what I think of as probably my most fun CEO startup experience, maybe organizational experience. I joined Nimble. We were about 20, Nimble Storage. We were about 25 people or thereabouts when I joined, just had launched the product. I'd been on the board for a year prior to joining as CEO. And so it was really pre-revenue. And over the course of the next 6-7 years, the company became a public company and then went on to be acquired by HPE. Just about a month ago, I had the entire Nimble team at my home for dinner. So it's more than sort of the milestones that are business milestones. I remember it was another place where the culture felt exactly like the NetApp culture. Almost everyone I meet from there talks fondly about their time at Nimble.
For sure.
I then left, took a year off and wanted to do something completely different from hardware and infrastructure, which is ironic considering where I came back to, but went to a company called Sysdig, partly enamored by the idea that Kubernetes was going to become the basis by which cloud applications were built. Sysdig was really an observability and security company for containerized microservices. Again, joined pretty early. So I think we were about 80 people when I joined, just under 5 million in ARR. I left about 6 years in. We're now, Sysdig is now about 120 million, 600 people, successful, very strong in container security, an open source pioneer in sort of cloud native container security. But for a couple of reasons, mostly to do with AI, I decided it was time to leave Sysdig. So just the last part of my journey and arriving at Clockwork. For the last year or so when I was at Sysdig, we had already started to embrace AI to try and bring agentic security to bear within the Sysdig platform. And I'm seeing firsthand how transformative AI can be when used well. I also realized as an existing company that has existing customers, a pre-existing architecture that you've built on, you can do a lot to embed AI, and Sysdig is doing that really successfully. But two things struck me. One, the next decade and a half, every product is going to be designed ground up with AI in mind rather than embedding AI. And the second thing that fascinated me was, as much as you can think about companies that use AI, I was fascinated by the underlying infrastructure and the underlying models, the underlying actually foundational layer itself that was then feeding these companies that were using AI. And so I decided I was actually going to retire after Sysdig or do something a little less intense after 17 years of startups. But the draw of AI was so strong, I wanted to go back to doing something in the AI space, and ideally a startup, which is always sort of my preference. And so that's how I came to Clockwork. And I'll talk a little bit about, I knew the founders of Clockwork and so on, but that's what brought me to sort of Clockwork in many ways.
That the lure of AI is incredible because it
exactly.
is such it's a unique period of time. I've never seen anything like this in all my years in IT.
I could not agree more, Chris. I was on the board of Clockwork I joined the board last year, and then about 6 or 7 months ago is when I came on full time as CEO. But it's hard to exactly characterize how so much change can happen in just 6-7 months of even within Clockwork.
Yeah.
I'm just seeing the pace. I've never seen anything move as quickly as what we're seeing, whether that's at the infrastructure layer, whether that's at the model capabilities, whether that's in terms of how companies are embedding AI. It's just wicked fast.
Yeah, it's going to be an interesting hype cycle, right?
For sure.
We've seen these hype cycles before. There's just something very unique about this one. On one
side, I don't think you can look at AI as like one thing on that hype cycle, because I think there's things that are in the trough of disillusionment, peak of inflated expectations, and the plateau of productivity all at the same time. You know, because there's so many different things going on.
Sure. No, I get it. At the same time, I think from the people that aren't in the AI world, they're in panic mode. And for people like us that are in it, I understand why they have some panic, but we'll be okay. We've been here before. This is just the part of innovation. You know, it's everything's going to be AI. You know, back in the day, if you didn't have a cloud story, you weren't getting funding. You know, if you weren't going SaaS, that was going to be a tough road, right? And now it's if you don't have AI, you're not going to get funding, and no one really cares. But ultimately, I do think the bubble is going to burst, and I think a lot of startups will fail. But I think that's a good thing from the perspective of we're going to learn so much in the next. We've already learned so much, but this is not done, right? Like, we're going to get into this, like some of the problems that are now out there that we need to solve.
Indeed.
It's absolutely amazing, and some of these,
for sure,
when we talk about them, they're almost elementary to me in some ways, but they're so incredibly impactful,
for sure. I think we are early in optimizing everything that goes into, from the infrastructure up to sort of agents that are delivering services to end customers. Everything is still very, very early in its evolution.
So why Clockwork? What brought you there? And maybe if you can give us a little bit of that history. I mean, I know it, but a little history of how did Clockwork actually become a company?
Absolutely. So I got drawn to Clockwork partly because of the problem they were solving, or in large part because of the problem they were solving and the technology they brought to bear. I happen to know the founder, Balaji, who's a professor from Stanford. I've known him socially for the last couple of decades, off and on. And then as I understood a little bit, the co-founder, Balaji's co-founder, Yilong, is in many ways sort of the thesis that he worked on with Balaji at Stanford is the foundation of Clockwork. And as I understood more of what was the technical foundation of the company, I got completely enamored. So let me talk a little bit about sort of the evolution of the company itself. Fundamentally, the company started when Yilong created this mechanism to synchronize clocks on a large, so within a data center, across data centers, across a large thousands of machines, using purely software where the clocks are synchronized to within tens of nanoseconds of each other. And so when you get accurate clocks in terms of drift between machines, there are the early 4 or 5 years. So the company was started in 2017. For the first 5 years, a lot of the use cases, frankly, it was operating as a Stanford group, if you will. So more as an offshoot out of Stanford rather than as a full commercial company. It was a small team of 4 or 5 people. And really the use cases were vertical market use cases. So we have companies that are Fortune 100 financial companies that want to timestamp their records so that they have accurate timestamps. There are companies that are crypto trading companies that are using this to make sure that they can optimize how to place a trade in the most efficient manner from a timing perspective. So there are a group of customers that were really vertical market customers, and that's where the company was focused for the first 5 years. In 22 and 23, the first big leap that happened was applying the fact that when I can synchronize clocks accurately, then I can accurately measure one-way delay, the time it takes for a packet to go from machine A to machine B, or virtual machine A to virtual machine B, or container A to container B. So I can measure that delay accurately, and I can measure one-way delay. So if time from A to B is different from B to A, most people basically estimate latency by taking round-trip time and dividing by 2. And so we're able to get accurate one-way latency. And then we built an entire network telemetry portfolio around that. That's the first time that the company leaped from being focused on vertical market timestamping applications into how do we optimize networking across large number of distributed machines, if you will. The step beyond just measurement came when we were able to embed control logic, so a software control plane to say, this is all still focused on TCP networks connecting containers and virtual machines. What we were able to say is now that we know the delay between machines, using software instead of relying on the network itself, can we do things like congestion management? So if there's a congested set of links, then let's slow down the pace of traffic so we can manage congestion. Can we do quality of service? So for example, if application A is more important than application B, let's prioritize traffic for application A over application B. So those two things, right, which is sort of taking our clock sync foundation, and we built what we call dynamic traffic control, which allows you to manage congestion and quality of service on networks, all applied to VM and container clusters, if you will. 24 is when the big breakthrough happened. That's when I sort of started engaging. Up until then, we were still on the CPU side. And what we realized was that GPU clusters used for AI training are the most demanding distributed applications that have ever existed in history. They have lots of unique properties. One GPU that's slow by a few seconds will make every other GPU in a distributed training job wait for that one machine. And so there's a whole bunch of properties where timing is extremely important. All computation happens across a large number of machines. So if we can take everything that we've done with respect to measuring the condition of the network, optimizing the flow of traffic on that network, and thereby improve what happens with GPU clusters, that is a big transformation. So that was really the opportunity that came to Clockwork in 24, and we started working on that problem. That's also when I sort of got completely excited. I'll talk a little bit more about what we do, but that's sort of long explanation of how I came to Clockwork and how Clockwork itself has evolved, Sandesh.
Yeah. Well, and the problem you're trying to solve, though, is kind of a non-trivial problem within the GPU cluster world. I mean, could you speak to like how much utilization, how little utilization we get out of these things?
No, absolutely. So if I describe the problem in terms of its business impact first, right?
Yeah.
Typically in these large GPU clusters, really well-managed clusters will get up to 50% in terms of utilization. Often, utilization runs in the 30 to 50% zone. Utilization being measured as if I have 1,000 GPUs in my GPU cluster capable of delivering X amount of flops, then what I'm really realizing is somewhere between 0.3 to 0.5 flops, right? And so that's one. Buried in that are many things, but the other really egregious problem is that if I look at 1,000 GPU cluster, for every 24 hours that I'm basically operating that cluster, I lose between 2 to 4 hours of availability on that cluster, where something disrupts my training job. I have to stop the training job and restart it from a previous checkpoint. And so I'm losing 2 to 4 hours, which of course feeds into your cluster utilization, but it also feeds into the fact that your jobs are taking longer, that basically some number of people on your observability team have to quickly find out exactly what happened and correct it. So observability, so there's an emotional aspect when failures happen that's as daunting as the lost utilization, right? No operations team wants to feel like things are always failing. They don't have complete control. So that's really the nature of the problem. Low utilization, very high failure rates. Every incident takes a long time to detect and remediate, and therefore your training jobs take much longer to complete, as much as 2 to 2.5x longer than in a theoretical best, if you will. And so that, in a nutshell, is the problem.
Yeah, sorry.
No, please go on, Chris.
I was going to say, there's a reason why NVIDIA is a $5 trillion company now. These things are not cheap. So utilization has a huge economic impact, right?
For sure. You take $100,000 GPU cluster, you're probably spending $5 billion on that cluster in terms of the data center.
Yeah.
So there's a capital that you can think of, and that's sort of wasting $2 to $3 billion is just that's crazy, right? Crazy in terms of sort of how much opportunity exists to improve. But sort of equally significantly, that same data center will consume, let's say, 125 to 150 megawatts of power. And that means you're basically throwing away something like 50 to 75 megawatts of power. That's 25,000 homes that basically can be lit up all year long, right? Yeah. And so every data center, so that's wasted. I'm not talking about the total power draw, just the wasted. So there are so many dimensions to this problem of we are not yet really good at efficiently operating the underlying infrastructure and extracting maximum utilization. In a nutshell, that is the problem that we fundamentally attack. And if you think about sort of where does Clockwork intersect that problem, Chris, so AI workloads they achieve everything they do through a distributed communication process. A single GPU cannot do what you need done. So you're throwing thousands of GPUs to complete the job. And so really the bottleneck to how you accomplish whatever your workload is trying to do is all about communication efficiency. And that's why sort of we like saying that communication is the new Moore's law in AI infrastructure. That's because everything that you're trying to achieve from an AI workload depends on the efficiency, effectiveness, reliability of how these GPUs talk to each other in a GPU cluster.
Yeah. Yeah. Well, I mean, and I've heard it your company described as sort of the ways for GPU clusters. I mean, so
that's because everything that you're trying to achieve from an AI workload depends on the efficiency, effectiveness, reliability of how these GPUs talk to each other in a GPU cluster. It's helpful to start with sort of what are the three building block technologies, Chris, and we've touched on a couple of those, right? Yeah. So the first building block is and I'll talk through, there are three core building blocks. So let me walk through each one of those. The first one we've touched on is already our ability to synchronize clocks to within tens of nanoseconds. And as a result, sort of what we are able to do is to look at every single message. So you take a PyTorch job, you break that down into sort of what is a distributed communication. So there's a messages being sent by this collective communication library. That message breaks up into chunks. Those chunks are broken up into units that are sent over RDMA connections. And so you break it all the way from the application down to what's traveling on the wire, and you're timing everything that's traveling on the wire because of our ability to synchronize clocks very accurately. So the first thing we have is the ability to look at all communication, understand what's going normally and what's being delayed, map that to what does that mean for your PyTorch training jobs, if you will. So that's the first building block, is clock sync leading to really deep network telemetry correlated to the application. The second building block is what we term dynamic traffic control. So really it comes to, it's actually very simple. What we are able to do is pace traffic. So either slow it down when it's likely to be congested. So pace traffic. We can slice traffic. So we basically are able to say, if I want to slice it into 5 pieces and guarantee one versus the other, we can slice traffic, and then we can reroute traffic, right? And so that's really what this control plane does. We happen to plug it into TCP using instrumentation like eBPF instrumentation. We plug it into RDMA networks using RDMA APIs. We plug it into collective libraries like Nickel within NVIDIA or Rickle in the AMD ecosystem. So this ability to slice, pace, and route traffic works with different communication protocols, libraries, and APIs. That's the second foundational capability. And then the third one is what we call distributed state tracking. So, sorry if I'm, hopefully this is making sense, and I'll totally translate this. But because all these jobs are essentially being managed as a set of processes that are executed on large number of GPUs, imagine that one GPU fails. If you're not making sure that everybody is at a consistent point, then essentially you have to restart from the scratch, because where you fail, the job is hung and all the GPUs are at a different place, if you will, in that collective process. And so what we are able to do extremely well is understand what the distributed state looks like so that we can recover gracefully when failures happen, when links break. So that's really the third aspect of it, is understanding the distributed state in a job that's executing on large number of GPUs. And that allows us resilience and fault tolerance when failures occur. So if I step back, at the core, it's 3 breakthrough technologies, right? One is clock sync leading to insane telemetry. The second is dynamic traffic control that allows us to sort of pace, slice, and route traffic flows. And the third one is distributed state tracking that allows us fault tolerance, if you will. And so that's what we've combined. Now, if you think about what our customers see when they're operating these clusters, we have multiple large neoclouds that are now deploying us. These are among the world's most successful neoclouds. We have one of the world's leading, LinkedIn was on our webinar yesterday. We have one of the world's leading telecom companies deploying us, leading sovereign labs, and one of the top 5 hyperscalers, right? So good deployments that give us a broad sense of what we're seeing. And essentially, it's 3 things. One is observability. So we first get deployed because we give extremely good observability, particularly with respect to networking, but broad cluster availability. In fact, one of our neoclouds uses us to audit their cluster to make sure it's configured correctly before handing off to their customers. So really good observability of the cluster. Then the second, and arguably the most common reason why we get drawn in, or the biggest deal driver, is resilience. Our ability to keep a training job continuing without disruption when you have links flapping. Today, we're working on technologies that will allow us to survive not just a network link flap, but any kind of GPU failure without transmitting that failure up to the application and continuing non-disruptively. So fault tolerance is the second thing that we're deployed for. And then the third one is performance optimization. So just by using sort of load balancing, congestion control, how do we optimize the performance of the network and therefore the overall cluster? So that in a nutshell is sort of what we do.
Yeah, and I got to imagine the TCO on that is so easy too.
It is. I mean, honestly, I think it's if you just take the link flapping, this is sort of our analysis, right? So, and this is based on really good data, both published data from the likes of Alibaba and others that have really, Meta and others have documented failures in gory detail, but we've also seen this in our own customer base. For every 1,000 GPUs, you're likely to witness something like 150 to 300 failures a year. Failures in the sense that job restarts a year. And then you continue and say, let me do the math on those restarts. You're wasting somewhere around 200,000 to 300,000 GPU hours a year from link flaps alone in a GPU hours. So 200 to 300,000 GPU hours. So you can do the math on just that. Forget delayed time to production and all of that. Just on the lost hours at $2 to $2.50 per GPU hour, the math there itself, even on 1,000 GPU hours, you're getting to sort of close to $1 million. And that doesn't count the human cost of just finding problems. It doesn't count the delayed time to market of your products and so on and so forth. So I think the ROI has been easy enough to establish for sort of the value, Chris.
For sure. Hey, I just for a second, I'm noticing like the light behind you from the open window is like shifting, and it's like it's picked up, so it's got the little.
Oh yeah, can't see your face.
Yeah, it's starting to change the exposure, but yeah, that's probably a better bet. Perfect.
Apologies for that.
Yeah. No, it was just getting a little blown out there.
Yeah, no, apologies for that.
You said something, Chris. Thanks for saying something.
We have rain here.
Yeah, just so you know,
it started out all right, but I think the sun. While we were talking, the sun moved. And the clouds changed.
Makes sense.
Chris is the pro at this. I don't know if you know, but he's on multiple podcasts. So this is not his first rodeo.
I know his setup was impressive last time we saw it. So yeah.
I do 4 podcasts now. So
man,
it's crazy.
Yeah. Told you. Nerd talk.
Nerd talk.
Love nerd talk. Oh God, that's Chris's jam. One of the key takeaways for me and anyone that is watching, from an infrastructure perspective, there's a rejuvenation that is happening. However, I'm not seeing the average, Fortune 500 company building out these very large scale environments. The problem you are solving, just by its nature, you need thousands of GPUs.
That's right.
So if you're spending thousands, billions of dollars, it certainly makes your value proposition, very simple. But what my biggest takeaway was, I didn't realize how many failures there actually are.
Indeed,
and not just the GPU itself, but also the network. I just kind of felt like, why doesn't this just work better?
No, I think it will. It will take a few years. I think the ideas around how to make the infrastructure perform more resiliently, to have more observability built in, to have more resilience built in, to have security built in will all come. I think we're at a phase in the evolution of AI infrastructure, deployment of GPU clusters where speed trounces everything. And so everybody's going for larger data centers faster. And so there's not enough time to step back and design. And the other phenomenon here that's interesting, I want to come back to the question about enterprises and how many can actually deploy these versus how they'll consume AI. Will they consume it through the infrastructure layer, or do they basically consume it through some other cloud layer? But sort of what I was going to say is many of the people that are solving these problems are solving it in a bespoke manner for their own internal infrastructure. These are the OpenAIs of the world and the Anthropics of the world are likely solving these problems through software techniques that are specific to their needs. What you've not yet seen is the emergence of independent software companies that are starting to say, all of these are software value add on top of the underlying networking hardware, on top of the underlying GPU hardware, server hardware that we need to build out. That's existed. I mean, there isn't a Datadog for observability in the GPU world. There are many, many software ISVs that are just, I think, going to emerge over the next few years. And that's certainly our vision. You asked a great question, right? So, this is something I think about all the time. Given the complexity and the cost of this infrastructure, I think there will be always sovereign AI that will be sort of deployed as bespoke data centers. And there'll be some really large enterprises that have the scale to justify building out their own AI data centers. For the most part, I think the emergence of the neocloud space is because you want someone else to take these problems away from you. And I think on the one hand, going all the way to an AWS and a Google, as they're becoming more and more AI-centric, it's almost like I don't need to consume their 150 cloud services or 250 cloud services. I just want a set of services tuned for AI. And that's where the neoclouds came in. They are really focused and therefore lower cost and more purpose-built for AI. Gradually, you're seeing those offerings emerge from the big hyperscalers as well. So I think most enterprises over time will consume that from either hyperscale public clouds or neoclouds that are becoming larger and larger and almost challenging the hyperscalers. And so there will be some really large enterprises, of course, that will do their own. But so for us, part of what I'm excited about when I see the success we are having with the hyperscaler I mentioned and the neoclouds, ultimately we are serving the tenants of these companies. Some of our products are more useful to the tenants than they are to the operator themselves, right? So for example, we do network monitoring, as I mentioned, and there's a lot of telemetry at that layer. But we also expose infrastructure dependencies all the way through a PyTorch lens. So if you're an ML team that wants to know why is my iteration running slow and what can I do to change that, we give you insights on how to correlate what you can change at the infrastructure layer all the way through to your training jobs.
Interesting.
Similarly, if you think about having a PyTorch job continue undisrupted when failures happen, what we're hooking into are hooks within Nickel, hooks within PyTorch itself that are relevant to the tenant of these clouds, whether you're running in a Google or an Azure, or you're running it in a Nebius or in your own data centers.
Yeah. Well, it's an interesting conversation that's been happening around the idea of like, have we, with all these foundational models, have we sort of reached peak training and now it's all going to be inferencing?
Yeah,
and then you start looking at like, well, but we've still got all this visual training data that's going to be coming in, and there's just like this is going to happen, this is going to happen. It seems like training is not going anywhere anytime soon in my book. But like, what's your perspective on that?
Yeah, so I think for sure, training I think is nowhere near the point where you can say there'll be sort of no need to train and everything will work on a foundation model.
Yeah,
I do think that it's hard for me to imagine more than a handful of foundation models that will be successful over time. So if you think about sort of truly massive foundation models, you'll maybe have less than 10 globally. I mean, there'll be some that countries will want to have simply for national security reasons and so on. But in terms of broadly applicable foundation models, but then let's take a simple example. I mean, actually, you called out image models as a great example. There will be a few dozen companies really specializing on image-centric models. You take automotive, Tesla is at least publicly known to have deployed somewhere between 50 to 100,000 GPUs just for training automotive. And it's not likely that there's going to be a single model that Volkswagen and Mercedes and everybody else will use. So the automotives, there will be a couple of dozen self-autonomous driving models that will exist. Similarly, drug research and pharma, you'll continue to have either not necessarily ground-up models, but pre-training and fine-tuning, and there's a whole bunch of... And so when I think about it that way, I'm convinced that there will be several hundred large companies doing training.
Yeah.
I don't believe, Chris, that there will be tens of thousands of enterprises doing training. They may do some amount of sort of fine-tuning, but even that, I believe, is probably not going to be numbering in the tens of thousands. Inference, of course, is, frankly, every application in the world will be an inference application over time, right? And so I think that is truly extremely broad. The interesting thing about training is if there are 1,000 companies doing training, the infrastructure spend there is still enormous. What I also find interesting is that inference itself is becoming multi-GPU, highly distributed.
Yeah.
There are trends that are driving sort of as you have larger and larger context length and keeping the what's called KV cache, which is really the tensor translation of all the context, if you will, that needs to be in memory to produce the output when someone asks a query. The amount of context whose tensor values you're storing up front and to invoke rapidly when a new query comes in, that's growing into the terabytes of memory. And that's forcing a disaggregation of inference into multi-GPU inference, if you will.
Right.
And so that is bringing,
that sounds like a perfect application for this product I know named Clockwork.
Exactly. Exactly. We are finding that suddenly all the things we talked about as highly stateful, highly latency sensitive, multi-GPU training environments are becoming more and more true of inference as well. Yeah. And that's what I believe will happen even in the world of inference.
Yeah, I think right now the biggest challenge for AI is context.
Yes, exactly. Exactly. And there are some really powerful technologies that are evolving in the inference world to solve that, right? And so how do I store hundreds of gigabytes to terabytes of inference in an external storage system, and yet bring that into the memory of a GPU that's actually serving that inference request in a really fast manner using special protocols to move data fast for inference serving? How do I take an incoming query and route it to the specific GPU that has the context most readily available and is idle at the same time, right? And so it's slowly a communication optimization problem that you're starting to see for sure.
Yeah.
What's interesting is when new technologies come out, it's rare that they start immediately in these large, highly performant, complex environments.
Right.
And that's what's interesting to me too, is that if the customers that you have, if you can help them and you can solve their problem, the others will be much easier. You've
for sure
gone after the hardest customers out there, and you're trying to sell them.
No, that's so true, Sandesh. It's both the boon and the bane of the problem we've solved and where that problem is most urgent. Even in our non-GPU microservices customer base, where we are optimizing sort of both detection of network bottlenecks in large-scale microservices and addressing the problem. The customer that I think we, in our public announcement of our platform, of our coming out party, if you will, we talked about Uber as one of the customers. And what's publicly known about Uber is they have thousands of microservices running on nearly 200,000 machines across 3 clouds, right? And so the scale where getting latency down right is matters the most is in these extremely large scale user-facing applications where a delay or an outage on an application means revenue is on the line, right? Rides are lost or food is not delivered. And so there's real implications to service levels there. On the GPU side, in a similar vein, where our ability to deliver resilience matters is when you're running thousands to tens of thousands of GPUs. And when you lose time, it's basically thousands of GPUs lying idle. So you're going to do whatever it takes to fix that. And so the good news is we are battle tested in some really large environment, and the revenue per customer is abnormally high compared to all my prior experiences. The bad news is failures are very, very, your product had better do what it's saying, because otherwise the black eye is dangerous.
Yeah, no doubt.
To a startup in particular.
Yeah.
I could keep going for hours. We'll try to land this plane.
We have already just blown through our time. So
no, I apologize, and thanks.
Well, and I'll tell you, man, the first problem you solved is a really interesting one too. And I feel like we almost need a podcast just to talk about that technology.
Clock sync.
Yeah, to get it down to that level of granularity is really interesting. I'd be very curious.
Chris, this is the honest truth. When I first, even though I knew the founder for 15 years, my interaction with Clockwork started when a headhunter called me and described this company that had solved this clock sync problem. And my first reaction was, look, I've been in tech for a long time. This is a very old problem in computer science. How do you synchronize? And frankly, if clocks could be synchronized to that level of accuracy, databases would not quiesce in order to do housekeeping. Storage systems would not quiesce in order to take a snapshot. They would just rely on timestamps to say, I can create a snapshot and so on. So I'm like, I'm not sure I buy what you're saying. And so, and in fact, he then sent me the paper, the Usenix paper where this was presented. And that's when I realized, oh my gosh, these are people I know well. So let me just go ahead and know that's what they were working on. And so I agree with you. It's an extremely interesting problem.
And that it's all in software. That's the thing that really gets me, because I'm not I'm like trying to envision how you would do that. And
that's right. You're of course right, because this problem has been solved through hardware. PTP has solved this to the same levels of accuracy, but with very specific hardware and a smaller number of machines.
Like
exactly.
Yeah, no, super interesting.
So cool. Well, landing the plane. Before I ask you this question, I just want to know, is it okay to talk about Torch Pass?
Yeah, no, I alluded to it by saying we're now surviving other GPU failures. That's what we're working on. Okay. We're actually in alpha with customers.
I'll tee you up for that. I just want to make sure that was okay. I don't know where you were at.
No, indeed.
So Suresh, what is in store for Clockwork now, both from a technology vision and strategy as well as the company?
Yeah, so I think I'll start with the technology. I think the vision we have of a software-driven fabric has so many places where I think we can add value. I'll call out two initiatives in particular, Sandesh. The first one, I talked about our current product capability to survive network link flaps and keep training jobs running. Mm-hmm. We're working on a project internally. We call it Torch Pass, but basically what it's aimed at is the ability to survive any kind of GPU failure and continue to operate training without letting that failure disrupt PyTorch jobs, if you will. So non-disruptive, fault-tolerant training in the face of any kind of GPU failures, not just network link flaps, is one of those projects. The second one is really being able to allow RDMA storage and TCP flows to coexist on a single Ethernet fabric. Specifically, RDMA requires a very separate set of configurations on underlying Ethernet. Even if you use Ethernet Rocky V2 is how you deploy RDMA on Ethernet fabrics. And then TCP, of course, is extremely well known. Traditionally, the two behave extremely differently. TCP anticipates losses and uses losses to control congestion. RDMA requires lossless networks. And so typically to deploy them, you've had to physically segregate the network in very complex ways. Our software very trivially allows you to run both RDMA. I don't say trivially, I should say in a very simple manner, allows you to run RDMA and TCP on a common underlying Ethernet fabric. We're very excited about this. It's early stages. We have one of the largest hyperscalers trialing this in their environment, but it can lead to massive cost reduction and simplicity. So those are a couple of, but the larger vision of ultimately allowing software to write, to really optimize distributed applications on commodity networks. So these are examples of what we're doing next that go in that direction that I'm excited about. As a company, to be honest, what's top of mind for us is just scaling the business, both in terms of customers, but really scaling the employee base as well. We're based out of, it's a young company. We've we've grown by almost 40% in the last few months, and sort of scaling the engineering team, scaling our ability to deliver to really large customers is top of mind. And so that's sort of something else I'm excited about. It's fun. We're at that stage where it's very challenging because it's finding good talent, especially given a strong desire for us to sort of be in one location, have everybody sort of literally work from a single office and so on is something that we want to hold on to as long as we can. And so it makes it even more challenging.
Right. Yeah. Well, you seem to like challenges, so I have a feeling you'll figure this one out.
I'm not sure you're going to make it to retirement. I think that it's always going to be that next project.
As long as life is fun, why bother retiring?
I know,
exactly.
Right.
Exactly.
This is retirement for you.
Indeed.
This is what it looks like.
Indeed.
Yeah.
Getting paid to do what you love.
It's interesting too, from a sales guy perspective, you have, it's not like there's thousands of potential clients for you. You're really focused on the big guys, but also this is a very technical sale. It seems like you really need to understand these components and how they're talking to each other, and all these resiliency issues and the visibility issues. There's so much that goes into this. So I think you know what I mean? Like, you can't just have an average sales guy.
You're right.
Yeah.
But I'll say one thing, Sandesh. I'll come to the first point second, but let me start with the second point of it's a very technical sale. I'll say yes and no, because I think on the yes side, when it comes to the how do you solve the problem and you explain how your technology works, you definitely need a strong technologist on the other side that can that can first buy into how you're approaching the solution space and then prove it to themselves in a POV. There is no deploying our solution without testing it in your own environment and so on. But the early phase of, can I get to that second technical conversation and a proof of concept, what we are finding is articulating the problems and asserting that these are what you're probably seeing in your environment. The person on the other side quickly says, exactly right. And so the problems are very easy to articulate. They are something that they're experiencing all day long. So our sales teams are able to go to the right, as long as you go to the right person and say, this is probably what you're experiencing. If so, we want to have a second conversation that's technical. That's proving to be not that hard. And so at least so far, I think Joe and the sales team is generally having a good time of being able to engage customers and get to the next conversation. Yeah,
it's a well-recognized problem.
The financial sale is what really makes me interested.
That's right.
That's right. I guess you're right. Yeah. So you need a technical person to explain it, but the business value is really clear.
Exactly. And Joe is our CRO Joe is very big on saying, look, I need to be able to translate this into what it means to the customer and their business. And he's saying, this is not hard for me to do in this case. And so that's step. On the question of how large is the customer base, something else I'm excited about is so today we focus on really two very targeted customers. One is neoclouds. There's about 180, I believe, of them. And sort of over time, it'll probably become a smaller number, but that's one group. And the second one is extremely large enterprises that have more than 256 GPUs that are doing training. Now, in the not too distant future, we are bringing something that allows you to address people doing training in clouds with a small number of GPUs in, let's say, an Azure or a Google, and bring some of the value even to those environments. And so that suddenly expands the group to a much larger audience of who we can solve. Part of it is also being very careful to say, let's front load where our sales and marketing efficiency can be highest, where you're sort of large deals with technically sophisticated buyers is where we can make the fastest progress. And so we'll stay focused on the first audience, but gradually we're seeing an opening up of the opportunity to even sort of cloud hosted training customers. And as I mentioned, inference is feeling very much like a distributed application. And so that's the next, that will open it up larger. So we see a pathway today for sure. It's focused on 500 to 1,000 customers as the focus.
But what a great place to start, because it's such a high value target. Yeah,
exactly. I worry more about branching out sooner than we should than about not branching out.
Yeah. Well, and I gotta imagine as you evolve over time, there's some foundational technologies that you guys have developed there that could be used in a lot of different areas.
Exactly.
Too,
I could not agree more, Chris. I could not agree more.
So we're going to have to stay in touch, Suresh.
Absolutely. Looking forward to that, Sandesh. Chris.
So exciting that where you're at in such a short period of time here. And just this conversation, and learning about Clockwork, I'm learning so much. I learned so much just through the conversation that I had with Joe and you, and just reading about you guys. I joined that webinar as well. So hopefully you're a frequent offender on here. And
look forward to it. And we're all living in fun times again. So
for sure.
Awesome. Well, thank you so much for joining.
Thank you. Take care.